What I've just said is rather critical. Let me say it again for reinforcement reasons. Okay. If we choose a subgroup H, and then we write down, based on H, the cosets of H, right, in this form, and then we do the group table, and then we get these blocks here. And these blocks are isomorphic. Well, the blocks have the appearance of a smaller group, right? So it looks as though these cosets are actually elements in the smaller group, right? Like this one would correspond to the D, and that coset would correspond to the C, and that coset would correspond to the B, and so on. Okay? Well, if these cosets are like elements of a group, right? That's what it's starting to look like, right? If these cosets are elements of a group, then these blocks here are the result of, so if these are elements of a group, you have to have a binary operation on the elements of a group, right? That's what a group is. It's a set and a binary operation, and with the four conditions on that set and the binary operator. So, so if we're going to pursue that line and find certain conditions on H, we need to know how do you perform a binary operation on these elements, on these cosets. So that's the tangent. I'm going to talk about that, and then come back to the main discussion. So I'm going on tangent at the moment. All right. Now I've just thrown this in. It's talked in the text a little bit. It's just to give you a foretaste of what's coming. If you take a number, any integer, and the last integer on the right ends in 9, and a second integer and the last digit ends in 7, then if you're told the product of those two numbers does not end in 3, then you know the multiplication was not correct. Right? Now, why is that the case? Well, any number that ends in 9 belongs to this residue class. Okay? Any number ending in 7 belongs to this residue class. And the product of any number that ends with 9 and another number that ends with 7, the result has to belong to the residue class 3, mod 10. Okay? So any number belonging to that residue class times any number belonging to that residue class, that product, AB, must be congruent to 3, okay? mod 10. So this is just this, right? Now, why am I talking about this? Well, it's a sort of foretaste, because what's happening here is an example of well, what I'll be talking a bit about next. They're just thrown in as a bit of a foretaste, and that's all. I mean, you can forget about it for a while. All right. Now, introduce a new notion, and this is, in a sense, the answer to this question. How do you find a binary operation on cosets? You take two cosets and you perform some kind of binary operator on the two. How do you define that? What does it mean? How to do that? Okay? Well, here's now let me see. I think in the textbook. So Barnard defines what I'm saying here. He describes it in these terms. I just liked it so strongly. I just changed it. I invented another term. Anyway, here's his term for what's going on here. He calls it operation induced by the operation little circle in A. It's the set A. Now I find that utterly unmemorable. Can't remember it. It's not very descriptive, so I just threw that out. And this is just my labeling. I just simply call it subset multiplication. Okay, so you have a set A. You have two subsets x and y of A, right? Written here, two subsets, and then you take these two subsets and, in a certain sense, you multiply them. Right? So you get a kind of product x y. Now, how do you define that? Well, I've got 3 bars here. That means by definition, right? In this context, it doesn't mean this. 3 bars here means congruent. Right? Here it means by definition. You know, met this distinction in the past several times. All right, so xy subset times a subset is defined as the set of binary operations on each member of x, big X, binary operator, and on each member y of big Y, the set. Okay, so you're forming all these binary operations, these ordered pairs. Now, x is before y here. X is on the left. So these are ordered pairs. The order is important. So x binary operator y often would be different from y binary operator x. Okay, so they're ordered pairs. The order is important. So this xy is defined as the set of all ordered pairs of this form, where your little x here is a member. It's for all members of big X and all members of big Y, the subset Y. Now, so if this has m members and Y has n members, then this set here will be of size mn. Okay, m times n. Right. Now here's an actual example of subset multiplication. So the set itself is D3, so the symmetry operations of a equilateral triangle. Now a subset X is just AB, right? Now this will have 6 members, right? 2 times 3. So here's a subset, X is a subset, and here's another subset, EBA, right? So we have 2 subsets. And so the product, the subset multiplication, the subset product, if you like, xy would be A times E, sorry, hold on. It's A times E and A times BA, and then B times E and B times BA. Okay? So you'll get AE and ABA, and then BE and BBA. Right? Here. Now that's just A. Now it's where is it? It's a dihedral group, and you remember ABA is just B. So this is just B. This will just be B. Now it's a dihedral group, so B squared is just E. So you can rewrite all this as A, B, B, A. Okay? Now we're talking about a set, so throw out the repeats. Just have each element of the set unique. So just one copy. So A, B, B, A will shorten down to just A, B. Right? So this set here is it's your xy. It's the product of 2 subsets. Right? So this process, this is me talking, not Barnard. I didn't like his labeling for this at all. I just call it subset multiplication. Right? Okay. Now we will use this technique, this definition of the product of 2 subsets to answer the question, what is the binary operator, the binary operation on 2 cosets? Okay? Now a coset is still a set, right? A coset is a subset of the group. Right? You don't have all the members in generally speaking, you don't have all the members in your coset. It's usually a subset. Okay. So, so if your cosets here are going to become members of a group, right, elements of a group, then you have to define a binary operation on these cosets. And the binary operation we're going to use is just subset multiplication. So you will do this kind of thing. In fact, well, you know, these are subsets of a group of D3, right? So the binary operation for cosets is subset multiplication. Right? Now I've run out of board, so we'll continue on after I redo the board.